So I've mentioned a few times how much I love the moon. And I'm going to say that several times probably before we get done here. But I never get tired of seeing it in the sky. Night or day, I look up and I see it and it just makes me smile. The moon, the moon is a natural satellite of the Earth. And that just means that it moves in orbit around the Earth. Did you know that our moon has a name? Our moon is called Luna. If you watch the moon over a long period of time, you'll notice that it constantly changes position in the sky. Even during the same phase, it will be in a different location than it was the last time during the same phase. This is because the moon orbits the Earth at an angle. So think about the Earth for a second. The Earth is traveling around the sun in a flat circle, and this is called the ecliptic plane. Think about a record player spinning. If you put a piece of clay on the edge of that record, it travels in a circle, but in a flat plane. The Earth mostly does the same thing. And that is what we mean by the ecliptic. The moon, however, does not orbit along this plane. It orbits at a slight 5-degree angle. And so as a result, it shifts its position just slightly back and forth through our sky. Now, the moon is significantly smaller than the Earth, about 1/4 its diameter, actually. If you were to hold a basketball next to a tennis ball, that would give you a good idea of the relative size of the moon compared to the Earth. Mass-wise, the moon has about 1/6 of the mass of the Earth, which in turn means that it has about 1/6 the pull of the gravity of the Earth. If you've ever watched the moon over a period of time, you might notice that you will only ever see one side of the moon. Our view doesn't change. This is called the near side of the moon because it's near to the Earth. The side that we do not see is called the far side. The reason for this is because the moon rotates very slowly. Now, by rotation, we mean on its axis. So if you imagine a stick going through the center of the moon and spinning, it's spinning around that axis. That's what we mean by rotation. So it actually takes 27.3 Earth days for the moon to complete one rotation on its axis. What's interesting is that it also takes 27.3 days to make one complete orbit around the Earth. So the orbital period is the same as the rotational period. So imagine that you're dancing with a friend. If you turn to the left 90 degrees and your friend stays in front of you, he has turned 90 degrees to the right. If you turn another 90 degrees, you're now facing the opposite direction from where you started. If he follows, he's also turned to face the opposite direction. So you have both made a 180-degree turn. Turn another 90 degrees, so does he. One more, and you're back to where you both started. You have both completed one complete circle. You have made one rotation on your axis, and he has made one orbital around you. And you only ever saw the front of him. All right, now I've mentioned that I love looking at the moon. There are just so many things to see on its surface. And just going outside and looking at the moon, we call these naked eye pictures or naked eye observations. Basically, that just means you're not using a telescope, you're not using binoculars, you're just going out with your eyes and looking at what you can see. You've probably heard of the man in the moon. During the full moon, go look at it. Relax your eyes a little bit and imagine two eyes near the top and a mouth near the bottom. And you can see that man in the moon. Did you know that there's also a woman in the moon? Under certain conditions, the right side of the moon appears a little bit darker, and you can make out the head of a woman looking up and to the left. Use your imagination a little bit, and you can also see a rabbit in the moon. Go out a few days later, and the shadow shifts, and you can see the cow jumping over the moon. We're going to talk a little bit about lunography, which is the study of the geography of the moon. Geography on Earth is the structures on Earth. So lunography is going to be the structures on the moon. At first glance, especially at a full moon, it appears to have a very flat surface. But if you look closer, especially as the light moves across the surface, we can see that there are lots of different structures. The terminator is the sharp line dividing the sunlit and the dark parts of the moon. Let's look at the Earth's terminator for a second. Notice how gradual the shift is from shadow to light on the Earth. This is because the Earth's atmosphere scatters the light. The moon does not have an atmosphere. And as a result, the contrast between light and dark is much more pronounced. The terminator is actually the best place to see features on the surface of the moon because the angle of sunlight will bring out those features. It gives the craters in the mountains a 3D look. When you look at the moon, there are distinct light and dark parts to it. The part of the moon that appears light in color is from a very fine layer of dust that has settled onto the surface. Meteor impacts send up a lot of material, and while the heavy particles settle down fairly quickly, the lighter particles take a longer time, and so they settle down on top. This is a fine layer of dust called regolith. Because there's no weather on the moon, those fine particles stay wherever they have landed, and walking in this dust will leave permanent footprints as well. The darker areas are the maria. Maria is a Latin word that means seas. These are relatively flat areas produced by lava flows and mostly made up of a rock called basalt. As you might imagine, they are named such by early astronomers who mistook them for the oceans of water on the surface of the moon. These cover about 16% of the moon's surface, and interestingly, only really appear on the near side of the moon. While these are known to be lava flows, keep in mind that these are ancient lava flows. The moon has not been geologically active in a few billion years. So this is the surface of the moon. The darker spots are the maria, and they have names. If you look up here at the very top, there's a maria, and it's called the Sea of Cold. Move down a little bit, and we have the Sea of Rains. The Sea of Serenity is right next to that, followed by the Sea of Tranquility. Over here on the edge is the Sea of Crisis. As we'll kind of see as the moon changes its position, this one kind of looks like it's going to fall off the edge. I think that's probably why it's called the Sea of Crisis. Down here we have the Sea of Fertility and the Sea of Nectar. This one is the Sea of Clouds. This one over here is called the Ocean of Storms. And then down here we have a Sea of Moisture. And over here in the middle, we have a Sea of Vapors. So these are your maria. The moon is also covered in craters. A few billion years of asteroid collisions will do that to you. Since there's no atmosphere, there's nothing in the way of an asteroid to slow it down or burn it up. This also means that there's no weathering on the moon or erosion to erase the craters that do form. A closer look at the craters show that they have a lot of really interesting features. For instance, the crater Copernicus has terraced edges that form from landslides as the material on the edges of the crater settled. Some of the craters also have a peak or two in the middle. Have you ever seen a slow motion of a rock being dropped into the water? In the center where the rock drops, there's a rebound of water straight up while the waves spread out. This is essentially the same thing. The impact of a meteor striking the surface of the moon causes the rock to act like a liquid. The peaks in the center of the crater are the rebound of that rock. Another prominent feature of some craters are rays. These are typically lighter in color than the surrounding rock. They're just formed from the material being ejected from the impact. Go outside and throw a rock in the sand, and the same thing will happen. I love this picture taken by the Apollo 12 astronauts. This is a side view of that Copernicus crater, and it gives you a little bit better idea of how the edges are stacked up as you go. There are several prominent craters that you can observe on the moon. Some of these are easier to see at different times. Again, when we talk about that terminator, you can see the craters especially well when they are close to the terminator. So be sure and go out and observe the moon every few days. Here are some of the main ones. Aristarchus is up here in the top left. Copernicus is not very far away. That was the one we just looked at. You can really see those rays spreading out from that. Kepler is right to the right of it. This doesn't look very much. This doesn't look like much right here. But again, once the terminator hits that spot, you can see it a lot better. Ptolemaeus is right below Copernicus. This one's a little bit hard to see during the full moon. Again, you can see that dark spot. That's the crater. Tycho is probably, besides Copernicus, the most obvious crater that you can see. Notice that ray system spreading out from Tycho. That was a huge impact on the moon. This one isn't quite as well known, but if you look when the terminator is right over here, so when you have a brand new full moon, what you'll see right along this edge is 4 craters just right there in a row. They all have names. I can't ever remember what names they are, but sometimes you'll see them called the Gang of 4. Now we're going to look at how the view of the moon changes as the terminator moves across it. So here we can see this right here is the terminator, right? So there's a part of a shadow over here that we can't see. Notice how these right here, see how those pop up so much better? This is the Sea of Crisis. You know how I kind of talked about it falling off the edge of the moon? And those 4 craters right there show up a lot better. You can also see up here. So we can see how that shadow really changes some things. As it moves across, again, really changes the surface of the moon, what it looks like. You can definitely see these craters here pop up as that shadow moves across it. Check this one out. See right here is that Tycho crater. Still right here, but man, you can hardly ever see those rays now. Whole bunch of craters that are popping up that you couldn't see very well in the full moon, but now you can see them really well. And those ray systems are a little bit less obvious. Here we go, moving across. See how those pop up? You can really see those shadows and really see how deep those craters are. And then as we move across, here if we go back, go a little bit faster. You can see how that changes. It's just kind of fascinating to see how that works.